Hey everyone, this week we are going to start talking about surface area of solids. We're on lesson 24, page 228, and we're going to go over some of the things that you should have learned in 6th grade. Follow along as I read this. In 6th grade, you learn to use nets to represent rectangular prisms. In this lesson, you will learn to find surface area of rectangular. Find the surface area of the building block in Ben's construction set shown below. So let's take a look at it. From what we see, there are 3 dimensions given: 1 inch, 2 inch, and 4 inches. Each of those represents length times width and height. What it wants us to do first is pull this shape apart. The first question: use the math you already know to solve the problem. How many faces does the block have? What shape are the faces? The faces are the smooth outer edges. So right here, and we see the top one there. We're not talking about the corners, we're just talking about if you were to sit this shape down, what would lay flat? There are 1, and remember, since it's 3D, we've got to account for each side. So one side here, be one side over there. One side here would be one side over there, on the top and on the bottom. So if there's 3 given, and we don't see the other ones, then we're going to double it. So 1, 2, 3, 4, 5, 6. Each of those are represented as a rectangle. So your answer for number 1, A, how many faces does the block have? It has 6 faces, and the faces are shapes of rectangles. For part B, it's asking us to take apart the prism. I know that there were technically 6 faces of rectangles, so we're going to have double to show for both sides. B says draw the top and bottom faces and label their dimensions. Okay, so the top dimension right here is what it's talking about. I also know that I can look down here and find the base of that dimension is 1, and the length or the width of that dimension, depending on which way you want to look at it, is 4. So when I redraw it, it's almost like I'm looking down onto it from, I guess, well, obviously, looking down onto the shape, duh. So if I have 1 inch by 4 inches, then I also have to have 1 inch by 4 inches here too, because this prism has 1 side and 2 sides. I'm going to do the same thing for the front and back. If I'm looking at the solid object, it has a front here and it has a back here. The dimensions given for that one are a height of 2 and a base of 1. Since I have 2 of them, I need to go ahead and draw both of them here. Height of 2, base of 1, height of 2, base of 1. Last, draw the side faces and label their dimensions. So I'm going to go back up here. I need to distinguish which ones are the side. I've got a height of 2 and a base of 4. Now the reason why my base wasn't 4 for the first one, because we are looking at it from a different view. Now if we were to lay it flat, it would have 1 and it would be 4. So now that we have all of our shapes labeled, the final question is, how could you find the surface area of the blocks? Let's go back up and look at one of them. Each one, if we do base times height, the area for the top and bottom would be 4. But there's 2 of them, so I need to account 4 for both of them. Same thing down here. Base times height is 2. So 2 here and 2 here. The third one, base of 4 times height of 2 gives us 8 and 8. You can see that all I need to do is add up the surface area of each face. So 4 plus 4 plus 2 plus 2 plus 8 plus 8 equals 24. This is what your first page should look like. All right, ready to turn to page 229. Moving on to page 229, let's read about, find out more. The surface area of a three-dimensional figure is the sum of the areas of all of its faces. A rectangular prism has 3 pairs of faces that are the same size and shape. The dimensions given: height, width, and length. All things we should be very familiar with. The top and bottom faces have the same area, length times width. The front and back faces have the same area, height times width. And the left and right side faces have the same area, height times length. To find the surface area of a rectangular prism, add all the areas of all 6 faces. Surface area equals length times width plus length times width plus height times width plus height times width plus height times length plus height times length. Or top, bottom, front, back, left side, right side. Here's the formula. 2 times length times width plus 2 times height times width plus 2 times height times length. How can you find the surface area of a cube with edge length 3 inches? Since we know that a cube is basically a 3D square, we know that the dimensions given are all going to be 3. So what we need to do is add the area of each 6 faces of the cube. A cube has the same side dimensions of 3 inches. So the area for one face would be 3 times 3 equals 9. So 9 equals 1 area space, and there's 6 faces, so we would do 6 times 9 equals 54 inches squared. You may ask, why is it squared? The reason why it's squared and not 3, even though it is a 3-dimensional figure, we are only wanting to know the surface area of it. So it's just how much is this flat part taking up? Not how much can I fill it, but how much is it taking up? If I were to pull this shape apart, how much room would it be flat laid out? So that's why this is an indicator for it to be inches squared instead of cubic inches. Let's look at page 230. So the problem is asking us how much feet, or how many feet, of nylon fabric would be needed to make the camping tent shown below, including the floor. So basically, in real life, if you had metal bars and metal canvas, or metal pieces, whatever, canvas pieces to go around to create a tent, you have to put the fabric over it, but you need to know how much fabric you need, so you need to know how much of the surface area it needs to cover. So there's your real world connection. It gives us the dimensions here. We can see that this is made up of 2 triangles and 3 rectangles. I want you to notice though that yes, the 2 triangles are the same size and the 2 leaning like wall sides are the same, but the floor is not the same as the other 2 rectangles. That's something important to know, because you're going to need to know how many times you're going to have to multiply to find all of the correct surface areas. So in this instance, yes, we have 2 triangles, but our 3 rectangles are not the same. Only 2 of them are the same. Let's look at some of the examples. It says you can draw and label the dimensions of the 5 faces of this prism. The tent is in the shape of a right triangular prism. The bases of the prism are 2 triangles that are the same size and shape. And they went ahead and cut out the dimensions for us. Base and height. And it also gives us the dimensions of where it meets with the rectangles as well. Shows that there are two of them. The other faces of the prisms are the three rectangles. The two leaning against each other are 5 by 8, 5 by 8, and the floor is 6 by 8. So if we see here, 5 by 8 is this one. Its twin is over here. 5 by 8. They lean up together to form here. But the bottom, we can see it has to match the base of our triangle. So we know that the base of the triangle has to be 6. So then that means the base of this also has to be 6 as well, because that's where they connect. So 6 times 8 is going to help us find the surface area for the bottom or the floor. You can use formulas to find the area of the faces. The area of a rectangle we know is length times width, and the area of a triangle is 1/2 base times height. I'm going to move on to 231. I probably will have to flip back and forth just because I don't have extra pages, and I'm sorry if you can hear crunching or anything. My little cat's on the floor eating. So just ignore that if you can. Okay, number 1 or number 2, whatever. It says, how can you find the areas of the faces of the prism? So first of all, before you even know what formulas you need to know what shapes you're working with. So obviously with the tent, we said we were working with a triangle and 3 rectangles. The 2 triangles are the same, 2 rectangles are the same, but the floor rectangle is not the same. It does give us the dimensions, so our very first step is to know the correct formulas and plug in the dimensions for each correct formula. So to repeat that, number 2, how can you find the areas of the faces of the prism? Plug in dimensions for the given formulas for area of triangle and rectangle. I'll give you just a minute to write that down. Number 3, do you have to find the areas of the 5 different figures? So that's asking, do you need to go through and do the formulas for each different triangle? Do you have to do it for each different rectangle? And the answer to that is no. We know that our triangles are parallel, therefore they're the same shape and they're the same size because they're also the base. So no, the triangular bases will be the same. But we do know that there are 2 of the rectangular sides. Don't let that confuse you and think that the 2 rectangular sides, I mean the 2 standing up and then we forgot about the floor. No, that means the 2 leaning rectangles are going to be the same, but then you also have to find the answer for the floor rectangle. So do you have to find the areas of 5 different figures? No, the triangular bases will be the same. 2 of the rectangular sides will be the same, and then the floor area. So you will have to find the area 3 different times. And you all feel free to ask nicely if the sub will pause the video here if you need to, or if need be, as you all like to make fun of me for saying. Okay. Number 4, what is the area of the triangular base? Show your work. So I'm going to flip back over for this. I see my triangle here. This shouldn't be too hard because we are able to identify, based on what we know already, the base of the triangle is the bottom. The height is given here. It shows us here because it's broken down into the right triangle. It goes up through the middle. So when I have my formula for finding the area of a triangle, it's 1/2 base times height, or you can think of it as base times height divided by 2. So now that I'm given my base and my height, I can go ahead and plug in my formula. I like to identify which shape I'm talking about. So triangle, here's my formula again, 1/2 base times height. Now I'm going to plug in the dimensions. 1/2 6 times 4 equals 24. Got to divide that by 2. So each triangle has an area of 12 feet. It's going to define the areas of the 2 rectangular faces. Okay, let's look at the side faces that are holding up the tent, that are kind of coming together to create that arch. So we have 5 and 8, a base of 8 and a height of 5, or a side of 5. No, technically, my bad. I have to remember to flip it upside down, or to flip it sideways, or whatever. So my base is actually 5 and my height is 8. Whichever way you want to look at it, honestly. Just as long as you know the 2 dimensions, it doesn't matter, because all you're going to do is do number times number. So to find the area of my 2 side triangles, I'm going to do 5 times 8, or 8 times 5. Then I'm going to get 40 feet. So each of the standing sides of the the triangular prism, this is going to be 40 feet, and this one over here is 40 feet. Now I need to find what it is for the floor of the tent. Just by looking at this, I see the dimensions I'm still working with are 8, because that 8 right here touches the bottom. I'm going to have to borrow the base from the triangle to know that this is also going to be the base of the floor, or the width, whatever you want to call that, because this is going to be the length of it or the height of it, and this is going to be the base of it or the width of it. So I'm going to multiply 6 times 8 to get 48. So the surface area of the floor rectangle is 48. Number 6 is asking us to go ahead and put it all together. What is the complete surface area of the tent? If you were to lay all the parts out flat and cover it with fabric, how much space would it take up? So we want to explain here what we're doing. We multiply each new area by 2, because there's 2 triangles, 2 matching rectangles, but do not double the floor area. Let's look back at our visual and talk about that. We have triangle here and a triangle here. That's why we're going to multiply that by 2, because if we were to lay that out flat, we would still have to make up for this area. So 1, 2. We also have to know the surface area of the 2 leaning sides. So there's 2 of these rectangles, so we need to multiply this area right here by 2, because it's also the area over here. So 1, 2 for those. The only one we do not double is because there's only one floor to this tent. You're not going to have a floor on the ceiling. So that's the only one you do not double. So knowing the area for our triangles, our 2 rectangles that are the same, and then our floor rectangle, we know to plug in 2 times the 12 feet for the triangles, plus 2 times 40 feet for the same rectangles, and then the 48 for the floor triangle. If we do all the math there, it adds up to 152 square feet. That is our surface area for our triangular prism. Use your own words to explain how to find the surface area of a right triangular prism. Multiply the area of one triangle by 2, which is what we did here. Add the areas to the 3 rectangular faces. So we found the areas of the rectangular faces, and we're going to add them all up. Basically, what we just did here, you're going to put in words here. Now let's put what we've learned to the test and let's try it down here. It says, find the surface area of the prism. Okay? It's a triangular prism, so I know that I need to find the area of the triangle and the area of the 3 rectangles given. I also need to understand that it looks here that not all of the sides of the rectangles are the same. So let's start with the area of the triangle. If I flip this sideways, because for me personally, that's just how I like to think of these. If it's giving me a right triangle, I want to flip it up to where the height is standing straight up. That way I can easily see the base is 6 and the height is 8. So I'm going to multiply, sorry if I'm just made you sick then. I'm going to multiply 6 times 8 to get 48, but don't forget you've got to account for that half. So divide it by 2. And I'm going to get 24. So the surface area of one triangle is 24. Just for this one. I can go back and plug in for the other 2. Or excuse me, actually the other 3, because none of these sides are going to be the same. I know that by looking at what they share. None of them share the same thing. So each one of them has a different dimension. So I'm just going to simply multiply my 2 triangles by the surface area of one. So 2 times 24 plus the surface area with the dimensions given of one of the sides of the rectangles. 6 and 7. And then I'm going to add that by multiplying 10 and 7. So you see that here? The 2 triangles times 24, 6 times 7, 7 times 10, and 8 times 7. Those are the last 2 given, 8 and 7, that we didn't work with. When you simplify those, you get 48 plus 42 plus 70 plus 56 equals 216 square units. Sorry, my cats are now playing with my cord. Okay. Number 9 says, suppose a cube has the same surface area as the prism in problem 8. Find the edge length of the cube. Now it's kind of making us have a little more information here because it's not only asking us to find the area, the surface area of one of the cube sides, but it's asking us to find one of the edges. So it's asking us to find one of the dimensions given for this. If this was a cube. Remember, a cube is made from a square where all of the edges and all of the dimensions are the same. So what I would do is I would take my total my total surface area, divide that by 6 because there's 6 sides or 6 faces in a cube. That means I have a face area of 36 for one of the faces in the cube or one of the sides in the cube. But it's asking me what is the edge length of the cube. So when it's asking me the edge length, remember we said it was one of the sides. So I know the face of a cube would be 36, but in order to get that 36, I would have to also divide that again by 6. So it would be 6 sides. So 6 would be your answer for that one. I know this isn't the easiest way for me to be able to teach you all, but when I'm not there, I don't want you to miss out on material. I will be back tomorrow. I should see you all for an hour. If you have any questions, I will go over this with you. I would go ahead and make a little mark next to some of them to try to remember what you want me to go over. And I will be talking with you all about page 232 and 233 when I get back.